Thank you, Sandy. Well, I want to start with a question. What do you get when you combine a nurse's knowledge of the human response to illness and health with an engineer's instinct for efficient design? Professor Patricia Flatley Brennan. With experience in critical care and psychiatric nursing as a foundation, she has built a career finding new ways to use state-of-the-art technology to improve human health. Dr. Brennan received a Master's of Science in Nursing from the University of Pennsylvania and a PhD in Industrial Engineering from the University of Wisconsin-Madison. Today, she has a joint appointment, serving as the Lillian L. Molman Bascom Professor of Nursing within the School of Nursing, and is the chair of the Department of Industrial and Systems Engineering in the College of Engineering. She is a fellow both of the American Academy of Nursing and the American College of Medical Informatics, and was elected to the Institute of Medicine in 2002. She developed the Computer Link, an electronic network designed to reduce isolation and improve self-care among home care patients, and directed Heart Care, a web-based tailored information and communication service that helped home-dwelling cardiac patients recover faster and with fewer symptoms. She is National Program Director of Project Health Design, a Robert Wood Johnson-funded initiative designed to stimulate the next generation of personal health records. Additionally, she leads the Wisconsin Techne Project, a federally supported, statewide nursing faculty development effort that will improve the integration of informatics and telehealth into nursing school curricula. Today, you will learn more about Dr. Brennan's newest venture, the Living Environments Laboratory at the Wisconsin Institutes of Discovery. Please welcome Dr. Patti Brennan.
Good afternoon. The chance of technology working is actually proportionate to the age of the people in the room. Oh, sorry. Better? No. Yes, there we go. All right. See, I told you. The technology will work best if there's a bunch of kindergartners in the room. We are in trouble. But we've had a good group of techno helpers today, so I think we're going to be all right. LOBES. Sounds like a clinical term. I'm not going to explain it just yet, but I want you to remember LOBES in the Wisconsin Institute for Discovery. This afternoon, I'm going to motivate the problems that challenge my research, and I'm going to talk about the opportunities offered by the Wisconsin Institute for Discovery, and then I'm going to tell you what my friends are going to be doing while I'm working on my problems there. I've been fortunate to speak to the Bascom Hill Society now 3 times in a decade. It's pretty lucky for me. So I looked back over my old slides to make sure I didn't reuse old jokes and didn't use old slides, but I thought I'd bring 2 to your attention. The first was from 2003. In 2003, I came back from a sabbatical excited about the possibility of genomics, of integrating technologies into bedside care, and I thought this was the absolute best place to do this. Had I known that the Wisconsin Institute for Discovery was less than a decade away, I would have been 10 times more excited. At the Wisconsin Weekend Away a few years ago, I talked about the dinner plate that knows what's on it. By using different kinds of technologies, we could actually make your plates help you know whether or not you can have that extra piece of cake. Now, this was an idea that didn't sell well. However, we do have lots and lots of opportunities for innovation in technology, and boy, is it a good idea. Because at one point, healthcare was only in a hospital. And now it's moved into homes and farms and neighborhoods and street benches. And if we don't have technologies present to support health in everyday living, we will not achieve the health goals of this country. We will never produce enough nurses, physicians, pharmacists, physical therapists, psychologists, social workers, whatever, to meet the health needs of every person in this country and in the world. And frankly, you don't want a nurse sitting at your bedside the whole time you're there. We're annoying. We tell you to get up, sit down, take a deep breath, turn over. You don't want us around all the time. But engaging people in managing their own care and managing their health experiences is what our work is all about. I want you to think about consumer-facing health IT. You as consumers, me as consumers, and the information technologies that should face us as we face our health problems. Nowadays, the technologies are built still in silos. Great thanks to Epic and all the big hospital information systems, we now at least have good clinical records. So imagine a person who has a heart attack at the beginning of the year, noted by the left-hand side of this red line, and travels through the year, seeing the physician, going to cardiac rehab, buying medications at Walgreens that have an RFID tag in place, back to the physician and again to the physician, some more imaging studies, and by the end of the year has survived, because most people in this country survive heart attacks now, and they do pretty well. The information technologies that we've been building till now have supported these vertical lines. They're silos, and they make sure that at the point of care delivery, you have the information that you need. But what about the care between the care? What about when you wake up in the middle of the night and wonder about something? What about when you're not sure if it's 2 of these at 4 o'clock or 4 of these at 2 o'clock? What about if your house could help you be healthy? That's what our team is working on. We're working on creating technologies that will fill in the gaps, that will bring health into the everyday lives of people. I'd like to begin by talking about work that's actually currently going on. We have been very blessed to receive a $10 million project from the Robert Wood Johnson Foundation to look at innovations in personal health records. You may have heard that term already. Personal health records are thought to be sometimes just a Xerox copy of your hospital record, but increasingly all the information that you need where you need it to help you take care of yourself. Our team, though, has been pushing forward the idea that information in a bucket is not enough to ensure health in your life. That information has to be a platform for action. So through Project Health Design, we and our partners around the country, and we now number 15 different teams, are looking at ways to use innovative technology for self-care and disease management. I'd like to show you a brief video about one of the projects.
My name is Clarence, and I'm 74. I value my independence more than anything. That's something I learned in the Army. So I was pretty worried about how I'd manage after my heart surgery, especially since my daughter Sharon already seems to think I need babysitting. Sure enough, she says she's going to come over twice a day to make sure I'm taking my pills. I tell her I'll be fine, but she's worried I'll miss a dose or take the wrong ones. Even though my veterans insurance got me this gadget, she just won't let up. And between you and me, well, I'm worried too. I'm not even sure I can turn this thing on, what with my arthritis. But my doctor didn't seem concerned at all. Pretty soon, I start to see why. I'm not much for technology, but even I could figure this out. I don't even have to use a keyboard. All I do is touch the screen, and it tells me how to get started step by step. First, I get all my bottles out. Turns out some of them have different names, but are the same darn pill. Other ones look the same, but aren't. This thing can tell the difference by scanning the barcode on the medication bottles. Then it displays pictures of the pills with their names, so I know what's what. Good thing, because once I almost took a double dose of my blood thinner, and that could have landed me back in the hospital. Plus, it turns out some of the pills in my medicine cabinet are expired, and others I don't need anymore. Those ones beep when I scan them, so I know not to take them. Now, I've always hated fooling around with pill boxes, but the tablet actually made it pretty easy. Not only that, but I'm able to set it to remind me when to take my pills. That made Sharon relax a bit, and she agreed to cut me some slack. And I have to say, it works pretty well. Just this Sunday afternoon, I fall asleep watching baseball, and my cell phone wakes me up. It's hooked up to my tablet and lets me know it's time. I pop the pills, and then it's back to my nap. Before my heart went, I used to come home from the doctor and realize that I forgot to ask her a bunch of questions. Now I have more doctors and questions than ever, but the tablet keeps me and my doctors on track. We keep a list of questions and review them during each visit. And if my question really can't wait, I can send it directly to the doctor and he gets right back to me. Over the weekend, I get a message that my new prescription is ready for pickup at the pharmacy. Sharon gets it for me, and when she arrives, I check the tablet to see if it has any side effects. It doesn't, which is good, because I've been planning to have my pals over for poker night. And these guys are sharks, so I gotta be at the top of my game. On her way out, Sharon tells me that she's going to start coming 3 times a week instead of twice a day. I'm just too difficult to be around. I laugh because I know it's her way of saying she's not worried anymore.
Technology can be helpful. It can be easy to use. It can be unassuming, but only if it's designed well. And in order to make effective technologies design, we have to understand people, we have to understand where and how they live, we have to understand where they get health care, and what kind of technologies are around. So we use a model from human factors engineering to create a model of design called context-aware design. And in that model, we're concerned about 5 environments. Where do people actually live physically? Do they live alone? Do they live with other people? Do they live in a house? Do they live on a street? Are they moving constantly, or are they in a stable place? We need to know what the physical environment is like. Do they have privacy? Can they store things? Do they have their own room? We need to know the social environments. Are they isolated, or do they have friends? Is there a family caregiver nearby? Is there someone who helps them, or do they have to think of everything on their own? These give us some cues as to what kind of technologies are most important. One of our graduate students in engineering right now is studying how culture affects social engagement around health. So she can build clinical records that actually allow family members to help each other, as opposed to restricting access and maybe making it difficult for a family member to know what's going on. We're interested in the psychological environments. What goes on in people's mind? What do they think about their health? Are they afraid? Do they think the doctor should take care of them? Do they think it's their own responsibility, or maybe their fault that they're having a health problem? These can affect how an individual engages with health, takes action, and maybe understands what's going on. What's the technological environment? We used to think that if we could only use the telephone line to get into the household, we'd have perfect telehealth. But you know, we have fewer homes with telephone lines now than we did a few years ago, because people have cell phones. So what once could run on a telephone line doesn't work anymore. Is broadband useful? Can we have Wi-Fi everywhere? We found that in some households, when we connect our computer systems to the telephone line using a special connection called DSL, our computer systems work better, but it completely obliterates the home monitoring system, the life alert system, and sometimes disrupts the phone itself. So this is pretty scary. So the technological environment we have to understand. And finally, we have to understand the health services environment. Do people have access to health care? Is it good health care? Is it the right health care for their age and stage in life? Understanding this context of health and health problems has been particularly important in driving our work. Now, we've come pretty far in a fairly short period of time. Colleagues here on the campus and around the country, students have helped us to understand that people will use technology. Our research shows that actually having technology to help people through transitions like discharge from the hospital actually helps them get better a little faster. But we're still not fitting easily into people's lives. There's 5 devices right here. I don't even know what they control, and so I'm not going to touch any of them. But think of your houses for a minute. You've got a remote control. You've got a telephone. Maybe you've got some kind of an alerting system or a connection to your clinician. All of a sudden, all these devices are moving into your house. We have to find ways to make them easy to use by understanding where you live. And this challenge has forced us to imagine, what if we could design information technologies for your house and your house and your house? What do we need to know? That's what's led to our project in the Wisconsin Institute for Discovery called the Living Environments Laboratory. Now, I'm not the only one in the Wisconsin Institute for Discovery, so I'm going to take a few minutes to give you an overview, and then I'll delve into my own work. The Wisconsin Institute for Discovery, according to John Wiley, is the product of 30 years of planning on this campus. It looks like it grew up overnight, but in fact, in the 80s, when there was a vision, how would we build the campus of the future, there was a vision for an interdisciplinary research center. With the great gift of the Mordred family and the state and WRF, we now have an institute called the Wisconsin Institutes, plural, for Discovery, and there are 2 institutes in the Wisconsin Institute Institute for Discovery. There's a Mordridge Institute for Research, and I'll talk about that a little bit, and the Wisconsin Institute, singular, for Discovery. That's where my group is. Oh, my group, the LOBES. Well, let's go back to the LOBES for a minute. The word LOBES actually is an acronym of all of the 5 teams, brought to us by one of the engineers in our group. He started to send out emails to us saying, "Dear LOBES." Now, as a nurse, I think lobes are things inside here, or maybe in here. They're somewhere internal. But this stands for the 5 teams in the Wisconsin Institute for Discovery. The Learning Environments Laboratory, that's my group. The Optimization Team, headed by Michael Ferris. The Bionates, tissue scaffolding, I'll talk about in a minute, that's led by Tom Turn. Epigenetics, led by John Deneau. And Systems Biology, led by John Yin. So the LOBES are the 5 of the teams in the Wisconsin Institute for Discovery. We were selected as a group of investigators by a competition on the campus. That competition required us to submit an idea. How would we, if we had unlimited space, well, if we had all the space we could ever dream of, and unlimited money, well, if we could have all the money we could have possibly get out of the state and the foundation, and all the time we had, well, if we could get out of the classroom more often, how would we reach and create new knowledge? And so we each created proposals that said, bringing together disciplines that don't ordinarily work together, what would we do? 26 proposals were submitted, 12 were selected for full development, and 5 of us are moving into the Wisconsin Institute for Discovery on December the 2nd. I'll now introduce you to our team. But we were all inspired by a fundamental idea called the Wisconsin Idea, very familiar to all of you. Bringing together the 3 key ideas: collaboration, work across the disciplines will improve, will accelerate, will increase the kind of breakthrough science we need to improve human health. Interaction, a physical space that engages people in conversation, lets us bump into each other, has full line of sight for vision, will bring us to a new way of interacting. Community, a space that brings in the Wisconsin and the Madison community to where science occurs and allows us to commingle with the community, will lead to the kind of development that's needed to make sure the future exists for what we need. This is how we look in our hard hats. We don't look very good, actually. There's the 5 of us. You'll see better folks in a moment. The scaffolding is still in place in the center of WID. I learned the other day that this scaffolding was the best way to safely create the beautiful skylight that's going to top off the building of WID. Because as you see in our building, we'll have glass everywhere, and the light will come through. We expect to have our teams entering the building in early October and accessible on December the 2nd for you to come visit. Here's a cross-section of what WID looks like. This is if you were standing on University Avenue looking into the building. There is utilities on the top of the building, skylights and open areas on either side. Those trees are actually inside of the building. There'll be a full greenhouse environment inside the building. There's research labs on the top 3 floors. The first floor is education and outreach, that gray area. And then the lower level you see where there's offices, specialty area, and storage. Keep that in mind because that's going to become important in a minute. What you'll probably most likely experience at WID is the first floor, the education outreach area. This is viewed to be a gathering space, a forum where people can come for casual or formal interaction. There will be 3 restaurants in the first floor of WID. There'll be a small dairy bar, fondly referred to as the DeLuca bar. There will be a nice restaurant that will have actually outside seating area and an alcohol permit, we're told. And there'll be a coffee shop. And the main entrance to the building will be on Orchard Avenue. It will not there will not be a main entrance on either University or Johnson, but there will be space where you can pull up right to the building and enter the building. The forum is viewed as a space where there will be, as I see, casual seating. That rounded area is a conference room. And a very interesting innovation is the conference room will have walls that can rise up when there's no conference going on in the room, or they'll come down to allow the space to be private enough. This conference room will seat 200 people, and the walls, the movable walls are already in place. We've seen they're on hydraulics, and they lift up into the ceiling. I still don't like to stand under them, though, because I can see all the workings, and I'm a little worried about the chewing gum and wire I see up there. there. The forum is going to be an open space. The upstairs areas for the faculty and staff research will also be open spaces. So if you see on the top half, we'll have full line of sight across the floors on all the second, third, and fourth floor. There'll be laboratories in the center, offices around the side. We anticipate that the Wisconsin Institute for Discovery portion of the overall institute will house 20 faculty members and about 150 students and staff. In the lower area, you see a depiction of what the first floor will look like. There are 2 targeted gardens, a Mesozoic garden and a Wisconsin natural garden, that will provide both relaxation space as well as oxygenation in the area. The building is designed to be one of the most energy efficient buildings in the state of Wisconsin. It is going to be LEED certified, I think bronze level, which is a fairly high level. Maybe even somebody might correct me on that. There are 75 geothermal wells that have been dug around the perimeter of the building, 300 feet down, that will allow the heat of the earth to actually provide heating and energy for the building. There's a plan to reuse brown water so that the water that's collected through the building and can create as a byproduct from the biological experiments will actually be used for flushing drains and flushing toilets and such. There's about 1 million feet of copper through the building, and this is providing state-of-the-art video and audio communication and network communication all the way through the building. It's going to be fantastic. Now, my space is going to be the best space in the building. I created with a group of people a concept called the Living Environments Laboratory. The Living Environments Laboratory is designed to accelerate the design of human technologies to improve human health. Remember I said in the beginning, we've gone pretty far. We know people will use the devices. We have a chance to learn about how these things fit into their regular care, but we don't know how they fit into their houses. So our team said, let's take a look at the environments where people live. Inside of the Wisconsin Institute for Discovery, we're going to be building a virtual reality environment that will allow us to create visually the look and feel of households. Now, in addition, though, we have 2 other spaces that are part of the Living Environments Laboratories, because we took seriously the challenge that was set out to us, that WID is both a place and a concept. Discovery occurs everywhere. So we're partnering with space in the School of Nursing, where my dean has promised me an entire apartment, fully instrumented, so we'll be able to understand how people interact in 3-dimensional space around healthcare problems. We'll be able to use both visual captures, image capture, as well as sensors to understand how best to create tools for people to use. We're also going to take advantage of the Biotron. Some of you may be aware of the Biotron. It's been here on the campus now for almost 30 years. The Biotron was built to recreate every environment on Earth, from under the sea to desert dry. We're going to be creating a chamber in the Biotron that looks like a very large tractor trailer. This chamber will allow us to manipulate things like vibration, grease, humidity, which will match the toxic and harsh environments of kitchens, bathrooms, and basements. We need to understand how these environments alter the way technologies work. And we also need to understand, frankly, how these environments alter the way people work with technology. In the lower level of WID, we'll have the Living Environments Laboratory virtual reality space. This is an image of what the lower level looks like. The angled space is Johnson Street. The straight line is University. There's a green circle on the left-hand side. That's where the virtual reality laboratory will be. It will be a 6-sided cave that has projections on all sides, and it will allow us to recreate a kitchen or a bathroom visually in 3-dimensional space. And in order to get the images for that, we'll take actual video of homes. So we will go to a home, capture the pictures, and then render them in a virtual reality space. This will allow a person to enter the cave and experience or work on a healthcare problem. Now, how big is this cave? Well, if you look in the upper left-hand corner, actually, I think this is a little bit better of a view. You see a cylinder and then a box in the center of the cylinder. The cylinder is a 30-foot wide, 30-foot in diameter space that will be 20 feet high. Be glass walls around the outside of it. The cave in the middle is a 10 by 10-foot room, and there will be using video projections on all sides of that room to recreate different environments. This will allow us to test how clutter in a kitchen or large spaces might work best. Most of the time when we design technologies for people, we think there's flat, clear tables with nothing on them. But I've been in enough households to know they don't really exist. If you're walking by the outside of the virtual reality lab, you'll be able to see in through the glass walls, and there's a small seating area at the far end. If you're in the inside looking out, this is what you'll be able to see. This is what you can see right now. We actually found, we took our architects down there the other day. That space, that duct, by the way, is about 18 inches off where it's supposed to be. And the builders were great. Mortensen's been fabulous. They're going to move it for us. They're going to send the bill somewhere. I don't know where. This is some additional space. It's probably a little hard to visualize this, so I'm going to give you a brief fly-through that the architects provided us to show a little bit more about what it's going to look like if you're walking down in WID. There's no sound associated with this, but here's if you're coming down the steps from the first floor of WID, you'll be moving into an open area. You see some offices around the outside, and you see lots of glass here. This space in this area is going to be administrative space, and the wharf patenting offices will be put in this area. Now returning down the hall as if we're walking down along Johnson Street to our left, but remember we're on the lower level. We'll be going through a doorway, and what you'll see here now is we're moving into the laboratory spaces. This glassed area on the left-hand side will be the server farm. There's going to be a state-of-the-art high-throughput, high-performance computer network service. The glassed area on the right will be Rock Mackey and Tom Turn's microfabrication space. The idea, again, is wide open spaces, lots of glass, and yes, in fact, there will be these poles in the middle of the hallway. I don't know why exactly they're there, except I think they're holding up the rest of the building. But they are organized the hallways around this way. The door that we're coming up to on the left is going to be the doorway into where our development lab is. We'll have a specialized development lab with a 16-foot wide screen to help our designers create interesting and ideal experiments for people to use in the virtual reality lab. Here the virtual reality lab is on the left-hand side. We're moving back into where will be a small gathering space area. People could sit here for lunch or for small meetings. And there is, in fact, a skylight over this area that will bring natural light in from the first floor down to the lower level. There's going to be some food storage back here. This I'm not really happy about because I told them where there's food, there's bugs. That's the rest of our lab there. And now this elevator will take us up to the floors in the upper floor where our offices will be. Along this hallway here we have space for students to sit, technical office staff on the left-hand side. And as we move through here, you'll be seeing some of the other shared offices. The lower level of WID will house not only my group's work, but also work of Tom Turn and John Yen. There'll be some biological laboratories here and some clean space for development. The space in WID will be open for your viewing, as I said, in December, but we've been able to get in and look at some of our opportunities there now. Our space is coming along, and we're pretty pleased. We're bringing in a 10-foot by 10-foot sheet of plexiglass that's 4 inches thick. In about 2 weeks, it'll form the bottom screen for the laboratory. And I made a terrible error last week, didn't realize I was making one, but I sent through a draft of the architectural bid request for bids to actually build the virtual reality lab, thinking I was sending it through to get comment on it, but it made it all the way up to the dean of the graduate school, who called me and said, this is $1 million and it only has your signature on it. I don't think we can do it with just your signature. You have to have a dean or someone say you can have it. So we don't have it quite built yet. Our work, though, it continues as a group in starting to hire faculty and starting to lay out the kind of experiments. We have been storyboarding what we're going to do. Now I'd like you to take a few minutes with you to tell you about what some of the other people in the Wisconsin Institute for Discovery are going to be doing while I'm working down in the lab here. Michael Ferris is a colleague of mine from Industrial and Systems Engineering and also in computer science, and his specialization is optimization. He's the only one of us who doesn't have a real live laboratory, and he thinks that makes him really special. It's probably true. Optimization is a particular type of mathematics. Now, you're going to see me study here because Steve Robinson is sitting up here, and I'm going to try to explain what his specialty is back to him. So we'll see how I do. Optimization is an application of mathematics that allows us to solve problems under constraints and come up with the very best solution we can possibly have. It's like creating a stock portfolio. How do you maximize your return when you don't want to lose too much, you're willing to take a little speculative risk, and there's a lot of volatility in the market. Mathematical programming optimization, according to Michael, rests on two key things, models and mathematics. Optimization models are designed to to improve the understanding of the underlying system that we can't really see or manipulate, but we presume there's going to be some kind of resource constraint. We're experiencing this right now in WID. We're a little short on offices, and we're trying to find the right way to give everybody as much space as we possibly can, as close together as we possibly can, without leaving any leftover space in the building. It's a challenge. Optimization, though, and specifically Michael's work in WID, is going to allow him to coexist with people who do studies like my work, where we're going to be taking constant signals from the environment and have to figure out which are really true signals and which are maybe just noise in this. He'll also work with the biologist, but I have a very practical problem of optimization that you might be able to make, oh gosh, this isn't quite it. He told me not to show this slide. He said, well, you can show it, but I don't think you can explain it, and he's right. This is what optimization looks like on Tuesdays. But here's the kind of problems that optimizers solve. Picture a plant in red, a company in red that has a series of plants around the country and has customers in the blue areas. Where should they locate their warehouse? What's the best space for that? Well, this is a kind of an optimization problem where you want to put the warehouse in the place that's going to minimize transportation cost, maximize accessibility or delivery time to your customers, and obviously not cost very much money. So in the supply chain framing of this, there's multiple manufacturing, there's many customers. Figuring out whether you should assemble things in one place and move them, or move parts, assemble them in parts and move them together, is another challenge they face. They look at questions like, what if we change where the distribution centers were? What if we got rid of some customers? What if we just used FedEx? Optimization models allow businesses to make very practical decisions. But they also help for healthcare. Another problem Michael's group has worked on is figuring out how to design an antenna to ablate, that is, to destroy a tumor in the liver. And the design of this particular antenna requires knowing how to create a probe that slowly gets entered into the body, that doesn't burn the individual, but gets close enough to the tumor. It requires knowing things like the size of the lesion, the size of the diameter of the probe, and solving that and testing the various ways to solve that is a different kind of optimization problem. So you're probably wondering, why is this guy who doesn't need a lab, who does a lot of stuff with math, going into a building that's laboratory focused? Well, it's the bottom reason right here. Engaged teams, embedding an optimizer with the teams as they're talking, as they're working, is the best way to make use of optimization techniques. So Michael is going to help the biologists better design the experiments they're going to do to figure out genetic structures. He's going to be able to help the people who are working on drug delivery create a system for drug delivery in the body, create a system for knowing exactly how big of a particle the drug has to be embedded on and how quickly that will be absorbed. So his skill, he's like the yeast that's going to make the rest of us work really well. Now, here's some of the rest of us. Tom Turn is a mechanical engineer, and his project is called Bionates. He's going to create scaffolds for tissue engineering. Basically, what tissue engineering is about, it's an interdisciplinary field that takes the engineering talents and the life sciences needs and brings them together. If you're trying to create, say, new skin, grow new skin for a skin graft, you need a cell source and you need a scaffold to grow those new cells on. The biomaterials, maybe polymers, maybe some other kind of inorganic material, provide the framework, the scaffolding that allows him to grow new tissue. Now, he's going to be working with three different concepts. He's going to be working with the idea of cells that have to live somewhere, the idea of signals that cells communicate or interact with each other, and the idea of scaffolds that cells have to grow on something. And in his laboratory, he's going to grow new kinds of tissues. This is both a biological and an engineering problem, so he's bringing together groups of people who have both sets of skills. He's going to look on trying to develop substrates, scaffolding, where the tissues can grow either inside or outside the human body, maybe to create something that it gets implanted and eventually the structure wears away and the natural tissue comes back to life. He has got to bring together issues about where the material comes from, what kind of nutrients it needs, what the life cycle of that information of that material is, and has considered things that are both synthetic biodegradable polymers as well as naturally occurring materials such as fibrogen and collagen. This has particular impact and import for drug delivery. Instead of swallowing a drug, the drug may be implanted and placed in a particular structure like a tumor. The scaffold holds it in place while the drug does its work, and eventually, as the drug is absorbed, the scaffold goes away. He's offered me a little more detail than I think any of us will need today about understanding the various challenges they face, but I want to call your attention to two of them. Rapid prototyping. His fabrication lab is going to test a lot of different kinds of scaffold, as well as high volume production. If we're really going to make a difference in Wisconsin by the discoveries in the Wisconsin Institute for Discovery, we have to not only figure out what they are, but we have to figure out how to get them into the community and get them into production. He has a team he already put together that includes both engineers as well as biologists, and he's doing particular outreach to high schools. He's interested in how to bring students in, so they're developing very interesting visual tools to use at the high school level to bring the concept of bionates into the knowledge base of the kids coming out of school. John Deneau is studying an area called epigenetics. This might be a new term for you, unless you read the Time magazine from a few weeks ago. Epigenetics are the proteins that control whether or not your genes actually fire. Epigenetics is the protein that makes two identical twins be slightly different. It makes and ensures that our genes and our environment work together. Epigenetics refers to the heritable, that is the inherited changes in the phenotype, our appearance, or the genotype that are caused by mechanisms other than changes in the underlying DNA. This is really exciting. When we first decoded the human genome, we thought, oh, we got it done. We know what the genes are, we know what will happen. And you know what? Even knowing the genes doesn't always tell you what's going to happen. And the reason why that is, in part, is because sometimes genes interact with each other or with the environment, but also sometimes the proteins that surround the genes act differently. So John thinks we should think about the genes as the computer hardware and the epigenome, the proteins that control it, as software that controls that structure. John's work is going to be particularly in looking at how cells become the kind of structures that we expect. So we start off with an original genomic cell, but see it differentiate into neuronal cells or liver cells or breast cancer cells. And he's particularly interested in understanding why do some cells get out of control, that is, become cancer. Beyond the genes, what is it about the epigenome? Why is this important? Because it may be easier to modify the epigenome than the genome itself. Genetic therapy isn't working as the way we thought it would, but modifications to the epigenome might make this be different. And the way you would modify this is by taking that long strand of DNA, you've seen that crisscross strand of DNA before, and instead of trying to break the strand, you wrap different kinds of proteins around it to make the whole gene function differently. Now, John's work is at the level of biology, but so is John Yin. John Deneau and John Yin are our biological components of the system, and John Yin's interest is actually in understanding how we can engineer biology to happen. He's more interested in the viral structure. He says that the grand challenges today is that the genome interacts with the environment. So as you're sitting here, you're interacting, you're feeling the air around you, you ate some lunch, you've been walking or not walking today. The genome interacts with the environment to produce the phenome, or our bodies, the traits of this. And he wants to understand how to make sure that given what we know about the genome and what we know about the environment, we can actually predict the phenome, the actual physical manifestation. In the 20th century, we focused on taking apart, knowing the organism, going down to understanding the genome. In the 21st century, what John's group wants to lead is knowing the genome, how can we create the life, the person, the health goals that we're actually about. And he's particularly interested in studying virology because viruses have a very short time life and have the ability to look at predictive consequences consequences of genetic structure in a much easier way. He's going to be bringing in 3 other kinds of biologists to work with the engineering team: an experimental biologist, a computational biologist, and an evolutionary biologist. The group of us coming together are going to be bringing 5 lobes of discovery into the Wisconsin Institute for Discovery. But we're not in the building alone. We're going to be sharing the building with the Mordridge Institute for Research. Now, when the building was first presented to us, they said there's going to be 2 separate towers, Mordridge here, WID there, and there the twain shall meet. Didn't work that way. We have imaginary lines in the floor that separate the private from the public sector. But what's important is that the Mordridge Institute for Research is a private endeavor. They will be engaged in a much more rapid development of discovery into economic value, into new products. They're focused in 5 areas: regenerative medicine, virology, new pharmaceutical devices, new medical devices, pharmaceutical informatics, and high throughput computing. The crux that holds them together and the work, and a piece that we're going to share with them and with, is their education and outreach group. So I want to close my remarks by talking a little bit about education and outreach. Susan Millar, Rich Halverson, and Kurt Squire are trying to improve society's understanding of science. They're not going to give people a nice lunch and then make them sit through all that biology again. They're going to instead try to figure out how to make science fun. The idea is to make the Wisconsin Institute for Discovery the go-to place in Wisconsin for people to understand cutting-edge science and know what it means in their everyday lives. Essentially, what Susan's group is trying to do is to optimize this little structure here. Think of the 2 axes of this structure being the user's challenge level, how hard is it for you to do this, and the value of the content, valued content along the bottom, with a 3rd dimension of the user's skill level. Now, if you or your kids or your grandkids play computer games, you know exactly what this means. A game that is challenging, keeps you interested, you keep doing it. Susan's group wants to take the concept of gaming, doing something that is fun and learning along the way, and applying that to the scientific knowledge we're trying to bring forward. The skill development is required because the science that's coming into society is not neutral. We need to think about this. This is an investment. This can grow the economy of Wisconsin, but it will also raise significant ethical and legal issues. We have to ask questions as a community. Educating the public about science, in part, will make new scientists, but it will definitely make better citizens. We want to motivate learning through social engagement and using kinds of game strategies, find ways to engage people in scientific thinking so they're able to join in the process. The Wisconsin Institute for Discovery offers a large group of people, but particularly myself, an opportunity to go through another 10 years of development, finding out new things, creating things for your home, and coming back to lunch in a few years and telling you what I've found. Thank you very much for your time. We have time for a few questions or comments. Yeah, Karen.
With the emphasis at the federal level on healthcare and improving healthcare and reducing the cost of healthcare, how do you see what you all are doing as fitting into our national priorities? Those things.
Karen, friends are supposed to ask the easy questions first. I will repeat it if I can remember it all. So Karen is asking me, with the emphasis on health care at the federal level, and particularly the emphasis on the complexity of cost and good quality of health care, how is WID going to contribute to this? First and foremost, I believe that we are going to be shortening the discovery cycle. So right now, the pathway from discovery to actual clinical use of new medications or of even clinical findings about posture and the effect of exercise on health takes 15 to 18 years. So we're going to try to accelerate that by using strategies like gaming and virtual reality to get it into people's hands faster. Secondly, we're broadening the definition of health care. So my group is specifically saying health care occurs not only in the clinic, but it occurs in your bedroom. And how do we get the right tools for that? The third piece that we'll be doing that I think will help with WID, the WID part of the Institute, is that we will be having a much closer proximity between the genomics discoveries and the home care delivery that I do. So we'll be able to learn about and build information tools for people as the discoveries are emerging, rather than waiting for them to emerge and then adding the technology on the end. Mordred certainly will be bringing in new products to market more quickly, we think, and things like that. So we'll also be stimulating the environment there. Thanks. There was a question back here.
Where are you going to park the staff?
Where are we going to park the staff? Where's your house? Where are we going to park the staff? I was told when I first was hired here that don't bother negotiating for your salary. Negotiate for a parking space. And it's very true. It's easier to get tickets to the boxes now than it is to get parking, I think. So we're going to do three things. First of all, the campus has a huge press to not having any of us park on campus. We really don't need cars on campus. Now, I wouldn't have believed that a year ago, but I now have a 16-year-old who drives. And I have learned that I can actually get along on campus without a car. Actually, though, there will not be any parking added in WID whatsoever. And there's not any parking being taken away with WID. There will be directly across from the street. Across the street from WID, there's the new Union South is being built, and there's going to be a hotel built with that, and there will be some underground parking there, so we're actually adding some spots in that area. We expect that the bus services will use the space on Orchard Avenue as a turnaround, so we will have more active bus service specifically to these corners. Right now the buses go on the perimeter of the campus, and this will draw them through. And bicycles don't take up as much space to park, so I think we'll be riding bikes more. Yes?
You initially said something like 27 or 26 proposals were cut down to 12, from which then 5 were chosen.
Yes.
But I had the impression from what you said that the other 7 somehow will be implemented. Is that so?
Well, no proposal ever goes unimplemented, and so you always have a way to reuse it. We've been challenged by the designers of the concept of the Discovery Institute to continue to engage with the campus as a whole, but specifically with others who have presented their their proposals in. Now, will they be funded through WID? No. There have been 2 sets of competitions through the Discovery Institute overall that provided seed money prior to this initiative, and the development of the proposals and the feedback from them is allowing people to go on to new funding sources.
Where would these groups then work? In their own laboratory?
Well, that's a very interesting question because what we're finding, there was the question is where would the groups work, and there was a thought initially when WID was built that we would vacate our own laboratory spaces and come to WID, and that would leave space in our own areas. But in fact, what we're finding is we're not going to do that. We're keeping our footprint in 2 areas, in part because our students will be in several areas, in part because investigators of today generally have multiple lines of research, so they end up using several spaces. Now, will we share the space? Absolutely. The virtual reality environment that I am creating will do best if we bring in the art department, the games department from education, the scientific visualization group from the Human Genome Institute. So we will be sharing a lot of our space. The microfabrication devices we'll have in this part of the campus will be second to none anywhere in the country, and so there will be other reuse of them. There's been a question as to whether there'll be commercial use of the space in WID, and at this point in time there is no plan to allow for that. But I would imagine that as the campus grows, there may be new kinds of relationships that we don't expect.
Jenny, I think we're out of time.
All right.
Do you want to mention something about when the building will be open?
Sure.
And when folks might be able to
Sure.
see the facility?
I want to mention 2 things. The first one is that we currently have a seminar running for the students that's given by all of the 5 WID investigators, the LOBES. And we meet Wednesday afternoons from 4:30 to 5:20 in the Mechanical Engineering Building, and I will provide Susan with the schedule for the rest of the semester. So if you want to learn more about one of the LOBES, please feel free to drop in. People do drop in sometimes just for one evening. It's a 50-minute seminar, and you're welcome to come and listen to what some of us are doing. Yes?
One more practical question. With so much glass in the facility, are you not concerned about a heating and cooling problem?
I can talk to you a little bit about that afterwards, but basically there's a double skin. So there'll be actually 2 layers of space, and I can explain how I understand them to be making that more energy efficient for us. The second part that I'd like to invite you all to is there'll be a grand opening of the building on December 2nd. There'll be a week-long series of events, including arts performances that have been commissioned for the space, tours of the laboratory. We will have the virtual reality lab open at that time, and we will have activities so you can go into the lab and test it out and see how you do with home care tasks. And there will also be public space beginning in January of next year, 11 months from now, that will be open on an everyday basis from 7 in the morning till 10 at night.
Thank you.
Thanks very much for your interest.